Our sun is a fascinating object. It is a giant ball of hot gas that sustains life on Earth. The sun is also incredibly complex. It has many layers and features that scientists are still trying to understand. One of the most mysterious features of the sun is its corona. The corona is the outermost layer of the sun's atmosphere. It is a region of extremely hot plasma. The corona is usually hidden from our view by the bright light of the sun's surface. However, during a total solar eclipse, the moon blocks out the sun's disk. This allows us to see the corona as a beautiful, pearly white halo. The corona is much hotter than the sun's surface. The surface of the sun has a temperature of around 6,000 degrees Celsius. However, the corona can reach temperatures of millions of degrees Celsius. How the corona gets so hot is one of the biggest mysteries in solar physics. In this essay, we will explore the fascinating world of the stellar corona. We will delve into its layers, its incredible heat, and its impact on space weather. Join me as we unlock the secrets of the sun's magnificent crown. To understand the corona, we need to picture the sun's structure. Think of it like an onion with different layers. The innermost layer, the core, is where nuclear reactions power the sun. Moving outward, we encounter the radiative zone. Here, energy from the core slowly travels outward in the form of radiation. Next is the convective zone. In this region, vast plumes of hot plasma rise, cool, and sink back down, much like boiling water. Finally, we reach the sun's visible surface, the photosphere. This is the layer we see from Earth. It's where sunspots, cooler regions caused by magnetic activity, appear. Above the photosphere lies the chromosphere. This thin layer is hotter than the photosphere and emits a reddish glow during eclipses. And finally, extending far out into space, we have the corona, the most mysterious layer of all. Each layer of the sun has unique characteristics and plays a crucial role in its overall behavior. Understanding the interplay between these layers is key to unraveling the mysteries of the corona. One of the most intriguing questions about the corona is its extreme temperature. As we move away from the sun's core, the temperature gradually decreases. This makes sense. You'd expect things to get cooler the farther you are from a heat source. However, something remarkable happens as we reach the corona. The temperature skyrockets to millions of degrees Celsius. This is like walking away from a bonfire and suddenly being engulfed in a furnace. Scientists have been grappling with this mystery for decades. The leading theory suggests that the corona's intense heat is linked to the sun's magnetic field. The magnetic field lines act like giant loops connecting different parts of the sun. These magnetic loops twist and turn, generating powerful electrical currents. These currents release energy, heating the surrounding plasma in the corona to extraordinary temperatures. However, the exact mechanisms by which this energy transfer occurs are still under investigation. For centuries, the only way to observe the corona directly was during a total solar eclipse. When the moon perfectly blocks the sun's bright disk, the faint, ethereal corona is revealed. These fleeting moments provided valuable glimpses into this mysterious region. However, with the advent of space exploration, our understanding of the corona took a giant leap forward. Specialized telescopes, such as coronagraphs, were developed to block out the sun's glare artificially, creating an artificial eclipse. These instruments, both on the ground and in space, allow scientists to study the corona continuously, not just during eclipses. They can observe its intricate structures, measure its temperature and density, and track its dynamic behavior over time. In recent decades, space-based observatories like SOHO, the Solar and Heliospheric Observatory, and SDO, the Solar Dynamics Observatory, have revolutionized our understanding of the corona. These missions provide a constant stream of high-resolution images and data, allowing scientists to monitor the corona's every move. Section 5. The corona's influence, space weather, and Earth. The corona may seem a world away, but its influence reaches Earth in the form of space weather. The corona is a dynamic environment. It is constantly changing and evolving. The sun's magnetic field lines threading through the corona can twist and snap, releasing bursts of energy and charged particles into space. These eruptions, known as solar flares and coronal mass ejections or CMEs, can have significant effects on Earth. CMEs are massive eruptions of plasma and magnetic field from the sun's corona. They can travel at speeds of millions of kilometers per hour. When a CME hits Earth's magnetic field, it can trigger geomagnetic storms. These storms can disrupt communications, cause power outages, and create stunning auroras in the sky. Understanding the corona's behavior is crucial for predicting and mitigating the potential impacts of space weather on our planet. The study of the corona is not just an academic pursuit, it has real-world implications for our technological society. Section 6. Coronal structures, loops, holes, and eruptions. The corona is not a uniform halo. It displays a stunning array of structures and features. One of the most prominent is coronal loops. These are giant arcs of plasma trapped along magnetic field lines. Coronal loops can extend for thousands of kilometers and glow brightly in ultraviolet and X-ray light. Another striking feature is coronal holes. These are regions of the corona where the magnetic field lines are open, allowing the solar wind, a stream of charged particles, to escape more easily into space. Coronal holes appear darker than the surrounding corona because they are cooler and less dense. And then there are the dramatic eruptions. Solar flares are sudden bursts of energy like solar flares. They release tremendous amounts of radiation across the electromagnetic spectrum. Coronal mass ejections, CMEs, are like giant bubbles of plasma and magnetic field that blast out from the corona. They can travel through space at incredible speeds, carrying billions of tons of material. Understanding the formation, evolution, and interactions of these coronal structures is crucial for unraveling the complex processes at work in the solar atmosphere. Section 7. Dynamics of the corona, a constant dance. The corona is far from static. It is a constantly shifting and evolving environment. The sun's magnetic field lines are constantly in motion. This creates a complex interplay of forces that drive the corona's dynamic behavior. One of the most intriguing aspects of coronal dynamics is the solar cycle. This is an approximately 11-year cycle. During this cycle, the sun's magnetic field flips polarity. The solar cycle is responsible for the ebb and flow of sunspots, solar flares, and CMEs. At the peak of the solar cycle, the sun is more active, with more sunspots and more frequent eruptions. This increased activity can have a greater impact on space weather. Understanding the drivers of the solar cycle and its relationship to coronal dynamics is an active area of research. Section 8. Exploring the corona past, present, and future missions. Scientists have been striving to unravel the mysteries of the corona for decades. They have employed increasingly sophisticated instruments and missions to observe and study this enigmatic region. Early ground-based coronagraphs provided valuable data, but it was the advent of space-based observatories that revolutionized our understanding of the corona. Missions like Skylab, YOCO, SOHO, and SDO have provided unprecedented views of the corona, capturing its dynamic events and intricate structures in stunning detail. In 2018, NASA launched the Parker Solar Probe. This groundbreaking mission is designed to touch the sun. It will fly closer to the sun than any previous spacecraft, directly sampling the solar wind and studying the corona's magnetic field. Future missions, such as the European Space Agency's Solar Orbiter, will provide even more detailed observations. They will help us to answer some of the most fundamental questions about the corona. Section 9. Conclusion. The importance of understanding the corona. The stellar corona, though distant, plays a crucial role in our understanding of the universe. By studying the corona, we gain insights into the fundamental processes that govern stars and their interactions with their surroundings. The corona is a natural laboratory for studying plasma physics, magnetic reconnection, and particle acceleration. These processes are not only relevant to stars, but also to other astrophysical objects such as black holes and active galactic nuclei. Furthermore, understanding the corona's behavior is essential for predicting and mitigating the impacts of space weather on Earth. As our reliance on technology grows, so too does our vulnerability to space weather events. The study of the corona is an ongoing journey of discovery. It is a journey that promises to unlock some of the most intriguing secrets of our universe. By continuing to explore the corona, we will not only deepen our understanding of the sun, but also gain a broader perspective on the cosmos and our place within it.